look quickly at two concepts, color model and bit depth. And to do this, I'm going to jump back over to our friend Photoshop, and I'm going to choose File, New from the File menu to begin the process of creating a new project in Photoshop. The New Project Properties window prompts me to enter in data that will allow Photoshop to understand exactly what type of graphic I want to work with in what type of application. So previously we found out that here I can define the width and the height and the resolution of my digital image by entering in numerical values into the appropriate fields. Here I've defined the width as 1000 pixels wide, the height as 800 pixels high, and the resolution as 72 pixels per inch. I have two other additional options down here that I need to take a moment to explain. One is called color mode, also known as color space, and the other one is bit depth. If I click on the color mode drop-down window, I'm presented with 5 options for defining the color space of the image: bitmap, grayscale, RGB, Cmyk, and lab color. For the most part, Cmyk and RGB will make up the two most common color spaces that you'll ever have to work with. I'm going to select Cmyk and talk about this for a moment. The Cmyk in Cmyk color space stands for cyan, magenta, yellow, and black. Cyan, magenta, and yellow are the primary colors of paint or pigments, and this color mode is used primarily for people who work in print. So if you work in a pre-press house dealing with the production of a newspaper print, magazine copy, books, etc., then Cmyk is probably going to be the color mode you're going to be most familiar with. Incidentally, the K in Cmyk is for the black channel. And this corresponds to the process of 4-color printing. In a print facility, when newspaper is published or printed on a printing press, there's actually a series of 4 presses that the paper has to pass through. Each press uses a single color ink. One press is assigned to the cyan channel, one to magenta, one to yellow, and one to black. And after the paper has passed through those 4 channels, the holistic impression of a full color image will be produced on the paper. For digital media applications, where we're not concerned with print distribution of a creative product, but rather distributing it through a computer monitor or through a television monitor, I'm more likely going to choose Rgb Color. The RGB in Rgb Color space stands for red, green, and blue. Red, green, and blue are the 3 primary colors of white light. So if you take the light from the sun, allow that light to pass through a prism, you can divide the white light into its 3 primary colors. If you've ever looked at a rainbow, you will see a multicolored display of the individual color channels that make up white light. And red, green, and blue are the 3 primary colors. Well, to the right of this, I can also choose the bit depth. And if I zoom in on this, you'll see that I have options here for 8-bit, 16-bit, and 32-bit color. I'm going to leave this set to 8-bit. That's the default in Photoshop. And this simply means that as Photoshop is processing my digital imagery, it's going to assign 8 bits, 0s and 1s, to each channel for each pixel. So if I'm in Rgb color space, every pixel has to have 8 bits assigned to it to represent the red channel, 8 bits for the green channel, and 8 bits for the blue channel. And if you multiply 3 color channels times 8 bits per color channel, you end up with what is commonly referred to as the 24-bit color model. 24 bits, 24 0s and 1s have to be assigned by Photoshop to represent the color value of each pixel in the image display. So you can imagine again, the more pixels I have in my image, the larger my file is going to be, because the more bits and bytes are going to be required to store the color values of every pixel in the display. I'm going to choose OK. And here's our new document window, and we're ready to begin designing within the window. So let's talk real quickly about color, and we're going to look at this diagram, which may look a little confusing at first, but if you think about it, it makes perfect sense. Along the left-hand column, I have 8 bits assigned to each color channel. I have a red channel, which is the top row, the green channel, which is the middle row, and the blue channel, which is the bottom row. And 8 bits are assigned to each one, producing 24-bit color. Well, if you multiply those out, each of these color channels has up to 256 possibilities. This simply means that I have 256 ways of arranging the zeros and the ones in a string of 8 bits, otherwise known as 1 byte. I have 256 possibilities for the red channel, 256 possibilities for the green channel, and 256 possibilities for the blue channel. And if you multiply those out, you get a rather large number down here at the bottom, which is roughly 17 million different colors. Okay, so if I go back over here to my color picker, then we can see here in the RGB sort of recipe window, this is where I can assign a value for each of the color channels from 0 to 255. By manipulating these numbers next to each of the color channels, I can produce up to 17 million colors roughly. To demonstrate this, I'm going to open up the color picker in Photoshop. A little smaller window here for you to see. And we know that if I select equal amounts, the full amount of the red, green, and blue, and I type in 255 for each of the values under red, green, and blue, that in my color picker I'm going to actually choose white. White is the full representation of each of those 3 color channels combined together. And again, this is sort of the reverse of taking white light from the sun, dividing it equally into its 3 color channels. I can do the opposite, and I can strip out the value of each of these and type 0. And assigning 0 to each of the 3 color channels is pretty much like turning the light switch off. I've removed any light from the display, thus producing the color black. And so in the language of digital media and light displays, the absence of light is simply darkness or black, and that's how the color black is produced. Concurrently, I can choose any of the individual channels and just type in the full value, and I'm going to get the pure version of the color red. If I type in 255 under the red channel and leave the other 2 at 0, and concurrently I can type in 255 under green and 0 for red, and I will produce pure green. I can also move around the color picker and pick my own shade of color. In this particular case, I'll pick a shade of blue, and you can come down and see what Photoshop has done in terms of the amount of red, the amount of green, and the amount of blue that need to be mixed together in order to produce this shade of the color blue. Right below the RGB property fields is this window down here that shows a combination of numbers and letters. This is my hexadecimal color code. So for any color that I choose, and I'll change here to a different shade, this hexadecimal color code changes, and I can copy that color code to another program by using this standardized way of numerically recognizing any one of those 16+ million colors in the RGB color palette.